Bismillah ar-Rahman ar-Rahim. Good morning, everyone. Today we will discuss together about what the Zener diode mean, and we will try to answer to solve many questions related with this topic, like what is the Zener diode, how we can benefit from it, if it has some features we can benefit from by using it, why we're using it, what the famous topic we can put it and try to benefit from these features, and what the breakdown voltage and how we can calculate the current inside or flow inside this diode, and if we have maximum current, or we can say majority current, minority current, or leaking current inside this diode when the current started to flow inside it, and many questions like that. Let's keep going to what is the Zener diode. The most important thing here, this figure, this image, we can know here we're dealing with Zener diode because these two simple things. It's different from the ordinary diode, and we will discuss together in which field the Zener diode will be like any ordinary diode, and in which topic, in which space or using this diode will be different from the other. What is the Zener diode? The Zener diode is a silicon semiconductor, like we explained it, illustrated it together at the previously lectures: p-n junction and the pleasure region, majority current, minority current, and something like that. But here we will dealing with some difference. Silicon semiconductor device that permits the current to flow inside it. We can use it at two directions, forward or reverse direction. The diode consists of a special heavily doped, and because that we will use it at something like regularity voltage, and we will discuss why at the next slides. Heavily doped p-n junction designed to conduct in the reverse direction when a certain specified voltage is reached. And we will discuss why we use it at reverse bias more than at forward direction. A Zener diode is a heavily doped silicon, like I said before, crystal diode which allows current to flow in the forward direction in the same manner as an ideal diode. That's mean like an ordinary diode. But in reverse bias, we will see some difference. It also permits the current to flow in the reverse direction, but when the voltage is above a certain value known as breakdown voltage, here that means V source bigger than VZ, some difference will be, and we will starting with dealing with a negatively huge amount of current at the something at Ni. I will define it at the next slides by using another image. What is a Zener diode used for? Why this topic very interesting to us? Zener diodes are used for voltage regulation, like I said at the first slide. But why? A reference elements, or we can say as a reference elements, surge suppressors in switch applications and clipper circuits, the load voltage equals breakdown voltage VZ of the diode. We will answer this question, why we use it like voltage regulation at reverse bias. What is that? Means the Zener diode can work. This can work at both sides of a reverse bias and forward bias, and both of them we can take benefits from it. At forward bias, like any ordinary diode, if we don't have ordinary diode, and between our hands we have Zener diode, we can use it instead of normal diode, and at the same time we can use it at reverse bias, and we can benefit from his feature, will be like a voltage regulator, and we will see answer why at the next slides. What is Zener diode and its characteristics? Sure, because this topic very interesting to us. That's mean here we're dealing with the great characteristics. Sorry, Zener diodes are heavily doped than ordinary diodes. Like I said, it's heavily silicon semiconductor doped p-n junction. It have extra thin depletion region. When we apply a voltage more than breakdown voltage, what will happen to the depletion region? The depletion region will vanishes and large currents start to flow through the junction. VZ, the voltage, the Zener voltage, we will dealing with this breakdown voltage, and we will see this phenomena at voltage. Zener voltage starts from 1.2 and until 200 volts. What is the Zener current? Like I said before, we have Zener voltage, and when we're dealing with reverse bias, we will dealing with something, or we will show something. I say to it, I named to it the breakdown voltage. Honestly, named the breakdown voltage, but the Arthur. Now, what is the current, Zener current? That's the Zener current here is the maximum current that can flow. The maximum current, that's mean here we have minimum current. That's mean we will dealing with leaking current. Leaking current, that's mean at the like the normal diodes, the leaking current will be near all these results will be near from zero, not zero, but near from zero. Let's come back to our lecture. It is the maximum current that can flow through a Zener diode and its rated voltage, some relation with the Zener voltage. Typically, that's meaning we have maximum current, we have minimum current. Like I said before, we can say leaking current near from zero. There is also a minimum current required for the operation of the diode. That's mean the characterizations, or yes, the features of this diode will select the amount of the minimum current or characteristics of this diode, kind of diode. What is the Zener breakdown voltage? What is the Zener current? Again, the breakdown voltage, it's a voltage at which Zener breakdown occurs when the sudden rise in electric current cases a junction. Let us use this image to illustrate to us. Here, the leaking current or saturation current starts from zero and be at the same, nearly the same, near from zero, but not zero, until breakdown voltage. Here we will show interesting phenomena, because the current will suddenly increasing, and we will start to dealing with negatively amount of current. At this point, at the voltage breakdown voltage, sorry, the breakdown voltage will be at the minus X, and the current will be at milliampere at the minus Y. Zener current, it is the sudden increase in current. He was focused on the slide, the increase, the suddenly increase current, amount of current, and like I said, negatively amount of current. How the Zener diode created an reverse bias. When reverse bias voltage applied to the diode reaches a close to the VZ. That's mean here the reverse bias near or equal the Zener voltage. The electric field here, we will dealing and focus on this slide is the most important slide on all these lecture. Here, the most important element at the Zener diode with reverse bias will be the electric field, because this electric field, the strong electric field, will focus and act on the depletion region by some way, and will take some electrons from valence band and make them gain more energy will be another thing. We will explain that together. The electric field here in the depletion region is strong enough to take the electrons from the valence band. The valence electrons which gains sufficient energy, huge energy, enough to make here to skip through to another to the electron band, sufficient energy from the strong electric field, and the depletion region will breaks bonding with the parent atoms. Like we said at the first slides, the depletion region, a reverse bias, will disappear and to allow to the current to flow comfortably inside it. All that because the sufficient electric field. All the electrons gain the sufficient energy, enough energy to make her skip from the valence band to conductivity band comfortably, because we don't have any depletion region. That's mean here at the situation we can say we're dealing like with any conductor, because the conductors don't have any depletion region. Now the valence electrons which break bonding with parent atom will become free electrons. The free electrons carry the electric current. Let me highlight it. From one place to another place. That's mean the electrons will be something like big cars, can carry the electric current from one place to another place at Zener breakdown voltage VZ. A small increase in voltage will rapidly increase in the electric current, like this previously image. Some simple amount, max amount, or by adding simple amount of current from this result to this result, we will dealing with suddenly increasing current. Now this image illustrates to us the narrow depletion region after the enough electric field. The important element, like I said, the strong electric field will take the valence electrons from the ions and this will be the important element, make the depletion region start to disappear or to be narrow here from ions, because that the narrow depletion region will dealing with narrow depletion region, because most of them the electric field take it from the depletion region, take some ions from some electrons from these ions, because that here we're dealing with narrow depletion region. At the previously diodes here n-type, that means majority electrons, minority holes. Here p-type, majority holes, minority electrons. And like I said, we're dealing with reverse bias, because here the positively terminal connected with the with n-type, that's mean with negatively terminal, and the same thing, the negatively terminal of battery with the positively side of the diode. Now, why the Zener diode is always reverse biased? Zener diode shows controlled the breakdown voltage. This is important, and allow current to keep voltage close to the Zener diode voltage, because that we use it at the situation like a regulator voltage, because the Zener diode shows to us controlled at the VZ and allows to the current to keep the voltage close to the VZ at this proportion. What is the Zener breakdown? Because we said it many times, and that's clear. This important element to us. Let's know what the Zener breakdown. It's a controlled version of avalanche breakdown in modified PN junction. Controlled version. It's occurs because of the high electric field. Why it's occurs? Because of the high electric field. And avalanche breakdown, it's due to the rapid collision. We will show some collision between the electrons, because the avalanche breakdown will be. What happens if the Zener diode is forward biased? Okay, we focused on the Zener diode at reverse bias, and we know what we use it at this situation like a regulator voltage. Now let's know what will happen if we're dealing with forward bias. But like I said before, we will dealing with ordinary diode at forward bias, but like take a look. It behaves like a normal single diode, like I said before, passing the current increasing linearly with the voltage. We know the current will be at the y-axis and the voltage will be at the x-axis. The relation between them at the ordinary diode, at the Zener diode, at the forward bias will be linearly relation between them. But a reverse voltage applied across the Zener diode attains the breakdown voltage visit of the device, and a large current starts to flow through the diode. Some big difference between them at forward bias and reverse bias with the same Zener diode. What is the most useful characteristic of a Zener diode? Like we said before, a regulator circuit or regulator voltage. It's a constant voltage a drop under condition of varying current. This makes it useful in the voltage regulator circuits, or we can say why we use it at regulator circuits, because at a constant voltage, at some result, constant result voltage drop under conditions of varying current, That's mean because the relation between the constant voltage with some amount of current. Another example, not just regulator circuits, or another example is the varactor diode. The varactor diode is a semiconductor device designed for use as a voltage controlled capacitor. Now we have two examples. Zener diode at reverse bias, very benefit to us because we use it like a regulator of circuits or voltage. And varactor diode, we use it like a voltage controlled capacitor. This is very important. This equation, that's right, it's very simple, but at the same time, it's very important to us because we use it to calculate some elements like current, power, or breakdown voltage by using this equation. And the next video, we will try to solve two questions, like I think. How do you find the minimum power rating of a Zener diode? We will use this equation, current equal potential divided on breakdown voltage, to find one of these three elements. It is the amount of voltage and current that the diode can handle. Current, like I said before, equal power divided on breakdown voltage. If we want to calculate the power, we will use this equation. That means power equal voltage dot the current, or we can say the breakdown voltage dot the current. What is the Zener current? Simply this, this, or we can say this small spherical current on this curve started until across the breakdown voltage specifically. It is the reverse current that flows through the Zener diode while at the breakdown voltage. That's mean here at the Zener knee, the breakdown voltage will be very important because until this amount of voltage, we will dealing with negatively amount of current. Zener voltage, the breakdown voltage of a Zener diode. This will be the last slide, and after that, at the next video, we will start to solve, like I think, two examples. What will a Zener diode do at a breakdown voltage? It acts like a voltage regulator. I repeated that many times because it's very important. The most important three things: the current equation, why, what will happen if we're dealing with efficiently with enough electric field, what will be inside the depletion region, and the feature of this diode, of this kind of diode when we're dealing with reverse bias, is the voltage regulator, because that I repeated all of that many times, and I focused on the voltage regulator more than the other. It acts as a voltage regulator. Why? Because it keep a nearly constant voltage, which is equal to the breakdown voltage across the terminals over a specified range of reverse current. Some relation between the breakdown voltage at constant amount with the reverse current voltage across its terminals or another points as a specified range. That's it. Our lecture is done. I will see you at the next video, maybe tomorrow. Thank you about your listening, your patience. Have a good day. It's me, Pastor Conving.